Hopefully that works. Okay, great. All right, cool. Yeah, ready? Yeah, go. If this works, yeah? Okay. Yeah, I'm going to talk about this thing, CUSF, which is the solution to all of our current problems. So you're welcome. But it's going to take a little while to give the whole explanation for why it is the solution to all of our problems. I only have 30 minutes, so we're going to do 15 minutes of this kind of background lead up to the problem and about me and the context and the things that I think are important. And then 5 minutes on this thing, and then I do think the Q&A is really where the magic happens, so I think that Q&A is good. I'm going to say some pretty audacious things in this talk, so it's only fair that people get to ask questions about them, but I do have a kind of a long intro slide. So I spoke at all 3 of the first scaling conferences. I was on the program committee for the 4th. This conference is supposed to be continuing in that vein, but what happened after the first 3, or really even the first 2, is that the scaling conferences quickly became pretentious academic junk conferences, so I stopped going. And I think this conference is also in danger of falling into that mold, although there were some good talks. But the other thing is that in December 2013, see, this is actually all important because it's very difficult for you to understand why CUSF is the solution to something unless you understand me and sort of where I'm coming from. So all this is actually important. But back in December 2013, I had this peer-to-peer Oracle prediction market blockchain technology that I called TruthCoin, which was supposed to be a sidechain L2, even back in 2013, which I quickly renamed to bitcoinhivemind.com, and you can actually go to that site and you can still look at it if you want. I had to rename it because people thought it was an altcoin. But this project basically became Polymarket. In fact, Polymarket is a much worse version of what I produced in 2013. But although I give them tons of credit for executing. But this speaks a little bit to what a lot of this talk is about, which is that we've had a little bit of slow developer action that has translated to billions of dollars per month in lost volume. And so that's part of what I'm trying to get at here. So the reason why this never turned on was because the company Blockstream that planned to deliver on peer-to-peer sidechains, they sort of never actually delivered on that. And so this next thing is that after they failed to deliver that technology, I had to do it myself, which began as this essay measuring decentralization from September 2015. And then it later became this Drivechain blog post, and then it became BIP300 today, and that's part of what I'm going to talk about in a little while. And then furthermore, I did this presentation in June 2016 called Sidechain Privatization, which basically anticipated not only MEV, but also the more complicated cross-chain MEV. And this led to an invention called blind merge mining in January 2017, which later became BIP301, and which today would be known as proposer-builder separation. And what this does is it automatically converts all L2 block value, including the transaction fees, any indirect value, DEX arbitrage, whatever. It transforms all of that value into L1 transaction fees. And miners don't even need to look at what is happening on the L2, which is hence the name blind. And then there's more stuff, but it's not really important. So, okay. I have a very different take, which I'm going to explain now on this L2 situation, which is, this is the end game for Bitcoin as I see it. These circles are to scale, which is why I use the monospace font here to get them to scale. But the left circle is, you have to understand what I'm getting at here, which is a little hard to explain, but the left circle is all the transaction fees paid to miners in the year 2022. And the next one over is the fees in 2023, which was the ordinals year. And the third one is back in 2022, all of the fees collected by all altcoins that are not Bitcoin. And then this gigantic circle, all the way on the right, is the value of all the transaction fees paid on Earth in 2022 if they were on Bitcoin. And so this is an estimation that I made. So of course I have to admit that I sort of eyeballed it, but I did look at quite a few things. I looked at the credit card company statistics. I looked at WeChat Pay. I looked at the Federal Reserve. There's a payments study. And I have a huge blog post where I go into the details. in writing, which I'm going to reference later in the talk, so you'll be able to look it up if you're interested. But basically, I came up, I looked at like the population of the world that is over 14 years old and all this other stuff. So it's basically $6.4 trillion in 2024, trended back to 2022. And then the 10 cents for transaction, because that's very low and it's significantly lower than basically everything else that exists. And it's so low, but you see, once you get to 10 cents, someone can only undercut you by around 9 cents per transaction. And I thought that's probably not enough to get people to switch networks. So that's kind of, I just eyeballed it as the equilibrium fee, but people are free to use whatever numbers. But the point is, it's a huge amount. And the other thing is it doubles in value. It grows at 6.2% a year. It probably goes faster than that. That's the lowest estimate. It's something like 3 per day per person above. Yeah, this is per year, right. So this doubles every 11 to 12 years. Yes. Okay, so why do I bring this up? Well, okay, the first question is a very important one, which is if Bitcoin took over the world, who would get this giant pile of money? And the current intellectual climate is pushing these non-mined L2s, which would include the Lightning Network, ARC, rollups, Liquid. These are not mined L2s, and by that I mean the transaction fees on the L2, they do not go to the L1 Bitcoin miner. Instead, they go to someone else. They go to the Lightning node that routed the payment, or they go to the LSP, or they go to the ARC SP, or they go to the sequencer, the rollup sequencer. So the money goes to someone else. And of course, that's kind of rude to the miners, but that's not really why I bring it up. It's really much worse than that. It's actually very, very interesting what will probably happen. And my guess, this is a complete guess on my part, but I don't see how it can be any other way, other than to produce this horrendously unstable situation that will end in a conflict between the L1 and L2 overall, and a huge incentive for miner centralization, and then eventually vertical integration between the L2s and the L1s miners. And then this vertical integration will utterly obliterate the entire L2 security model in the first place. The L2 will end up fully custodial, possibly even miner custodial, and then the value will all become MEV, in fact. I have a little bit more to say about that later. So the reason that let me explain a little bit more about this, which is to say, so the miners get this tiny circle, and then there's this huge circle above going to like the ARC supernode or something. The reason why this is actually important is that the miners have an extreme ability to affect the L2s. Every L2 is vulnerable to 51% attack by L1 miners. For example, the Lightning Network requires a L1 transaction to join the network, and it requires one to leave the network. And the Lightning Network only works at all if you can broadcast justice transactions to L1 whenever you want. And the 51% hash rate group can censor these transactions. And if you don't believe me, here's Rene Picard, who wrote the book, Mastering Lightning. He's saying exactly what I'm saying here. And this is the same for BitVM, where BitVM has like a justice transaction that is basically something like, if someone does something that they would not be allowed to do in the L2, you pull this on L1 and you can slash their bond or whatever. The different L2s are very different from each other, of course, but no matter what the L2 is, the miners can block the entrance and the exit if they can figure out what it is. So there's a little bit of animosity would go a long way. So basically, if we return to this example where you have like something like a Foundry LSP, or Antpool LSP, a Foundry Lightning on one hand, versus the Lightning nodes that are not backed by giant amounts of hash rate, then it would be completely understandable for the actual end user to get nervous about using the non-mined LSPs because they would not be secure. And the HDLC would really do nothing. And eventually the non-mined, the non-miner associated LSPs would go out of business, and everyone would use a miner LSP. All of the HDLC stuff would be superfluous, and the Lightning security model wouldn't even apply in this case anymore. And the interesting thing is that all of this, the whole L2 value, the giant sphere or giant circle, that would all become MEV, since it would now become mandatory to become a Lightning service provider. It would now, every viable miner would have to become an LSP, and they would have a monopoly as well, because it would be very difficult to start a new Lightning company now. And on the flip side, it would be difficult to start a new mining pool. So it would really be some kind of like super MEV. And so the bizarre thing, ironically, the only way to undo the MEV at that point would be to create a mined L2 and then hope that everyone switches to it. And so even if the ones on the left had succeeded, we would end up wishing that they had failed. In other words, the non-mined L2s are not going to work. They may work in the superficial sense of the software not crashing or the software being able to put transactions through for some people. But I think this means that they can never really be big. They can never really be a big success, because as soon as they're a big success, they'll never really be this, this huge circle. As soon as they are, miners will think, why am I getting this tiny circle and the LSP is getting this huge circle? We could talk about why the tiny circle will probably stay tiny on L1, but it's a different question. And then miners will think, well, why don't we start our own, mining LSP, Foundry LSP? And then they get into a fight, and it is a battle where one of the sides doesn't have any bullets. So instead, here's my proposal for the mined L2s, which I'm now calling 1313, to doing a math coincidence. But the details are in two blog posts of mine that are very old. I mean, this one is from February 2021. But basically, it's a very small L1 block size that we have already, and then 13 separate L2s distributed amongst users on the planet more or less geographically, each released one at a time as the previous ones fill up. And they start with what is the equivalent of a 13 megabyte block size that grows over time for each of them. And then this is the other one here. This is this post, all the world's transactions, where I talked about the estimates for how many transactions are actually in the world on a given year. And it has this table. And I have them, if they grow at those rates, and then it converges to a planetary scale by the year 2030, which is 9.8 trillion transactions per year. And so that is this schedule. And this idea, from the end user's point of view, is better than Lightning, which is the viable L2 today, in the following ways. I'm not going to list them all, but I'll list a few, which is like there's no channels, there's no interactivity requirements at all, there's no liquidity problems at all, there's no fee for liquidity as with ARC. You can onboard people directly to L2 without using L1 bytes, and the payments don't fail. And of course, 100% of the fees are passed down to miners instead of 0%. It actually has more benefits also. It actually slightly improves miner centralization by allowing faster and smaller cash outs from pools to the end hashers. And furthermore, it does not require any changes to Bitcoin Core at all, but it does require this thing CUSF, which I am going to get to eventually, pretty soon, I hope. So, and on top of that, I love the dev tooling talk. That's great. The software already exists today, so here it is. So we've built it, actually. And it even has a little GUI there up in the top right. So it has a wallet, it has interface. Bitcoin Core, that's the L1 is in the bottom left, and then the L2 thing is in the top right. You can't really see it right now, but this is the new CUSF version, in fact. So now I think I'll have a little bit to get through what this is. I think it's going to be kind of difficult to understand, but I'm going to try to explain it anyway. So, because some people will think this is such a small idea, it doesn't count as anything, and other people will think this is so drastic an idea that it is. So I don't know which you'll find yourself in, but CUSF stands for Core Untouched Soft Fork, and it threads the needle between these two roadblocks. One of them is this, which is that Bitcoin Core cannot soft fork anymore. These numbers are from BitMEX research. They are not mine, but I put them in this table. And this is a table of soft forks in Bitcoin's history. And you can see that we used to do one every 2 years or so. And now we do basically zero. I also took the opportunity to look up the time it took to get from the first, concrete mailing list suggestion of the idea to when it was coded and then when it was actually activated. And so you can see SegWit was 20 months and Taproot is 46 months. And I think if you have been paying attention today, you see that there's all these ideas, but everyone has this, for whatever, every single idea that someone has put forward, that's like someone's least favorite idea. And so there is no actual consensus on anything, and so that is why there's this log jam here. So this is the first roadblock. The second roadblock, though, is that you really cannot just switch away from Bitcoin Core to something else. That's too drastic of a change for a variety of reasons. Like to leave for a completely different client, it might disconnect you from the network, and it might you might wonder like who is going to maintain this in the long run. So you can't do that type of thing. There's no way to actually compete with Bitcoin Core with the second client. One reason is that they have these CVEs that are only disclosed to them. They're the only ones who know about these security vulnerabilities, which they sort of must keep secret. And so this is just one reason among many why you cannot write a competing client, basically. And so this solution here is that you keep Bitcoin Core completely unchanged, and you just keep, it's almost like a dependency or something. You just have it there doing its thing, same thing it did before. And then you release a second piece of software that manages the soft fork only. And that is called, that would be the CUSF activator or something. So after Bitcoin Core scans a block, it passes the block to like the opcat activator, for example. It scans the block again, and then if there's any opcat rule breaking over there, that's the only thing it's scanning for the second time. Then it tells Bitcoin Core to reject the block. And this makes the soft fork, it's much faster, safer, easier to understand. It's safer in particular because it's a little bit more reversible. You don't have to like restart the mining operation. You just add the second piece of software, and then if the second piece of software is low quality, or if it crashes or something, then it's just like not there. The soft fork temporarily deactivates in that situation, but it doesn't have to affect anything that is currently running. I mean, it's a nuanced question, but. Yeah, and so also, this is a paper here. I stashed it at this site. This is just a site that I grabbed quickly, bip300cusf.com. There's a paper there. You can check it out. This thing, the ordinalization of soft forks, I don't know if that will help people understand or make it more confusing, but like ordinals are like you have the existing thing and then you run a second thing that helps you make more money, and this is similar in that way. So I don't know if it's not exactly the same, but. And we have the software already. I did do it for BIP 300 and 301, and I also did it for opcat, the BIP 347 version that we heard about earlier today. So the software already exists, and you can fork this software, and you can make a CTV activator or whatever, if you wish. Okay, let's see. Okay, good. Almost 20 minutes exactly. So I think I will do this slide though, which is that, okay, this, in one sense, this is really no different than how any other soft fork would activate, but another way it's very, very different. So it has the same effect as a soft fork. I think one interesting thing about this idea is that most people don't understand what a soft fork is or what it's doing. And as a result, this is like the best way of explaining to someone what a soft fork actually is and why it's, mostly harmless. But it has the same effect, but there's two different software daemons, and there's, it is inefficient in the sense that the computer basically has to do twice as much work as to scan all the blocks a second time. But it's more efficient in the sense of humans because we don't have to get a pull request through Bitcoin Core because they do not want to do any controversial pull request ever. And as you can see, it's very easy to just manufacture controversy even about things that are objectively harmless. So, I think I will sneak this last one in here. So again, so just to get it into 3 bullet points, I think the idea is miners run this, to scale Bitcoin, miners run this BIP 300 CUSF activator. Bitcoin Core continues to do nothing, which they're very good at that, so. And then once 51% hash rate is running it, then this will activate. It will only activate for as long as they are running it. And then, of course, regular people can run the activator with their own node also. To do that, to validate the rules, which would be the full node in that case. And then the miners activate these mined L2s, and they collect money from them, and then Bitcoin has scalability, privacy, et cetera. And I have to compare this to, the alternative plan is to take the same people who for years have been overly optimistic about the viability of Lightning, and then wait for them to finish ARC or whatever, or some other thing where there's not even dev tooling for it yet, which is going to be way worse for the end user, and it's more complicated and more expensive, and it may not work at all, and then such that even if it did work, the miners won't get any money, which will lead to this conflict that I mentioned before, and then that will lead to this total collapse of the original security model anyway, and then all of that is, even if it takes too long for us to actually finish this, Bitcoin might be replaced by something else, because we can go very slow for a long time, but until we actually have, if it's possible to get 8 billion users of a certain coin, and then other people are trying to do that as quickly as possible, and we don't, then that doesn't look great for us. So I think, yeah, I have tons of extra slides, and I have even more stuff, but I think the questions are far more important. So if you don't ask any questions, I will do random slides.
Portland, and then we'll go
Yes.
yours.
You can maybe just yell it out, I can repeat it.
Okay, so my question is with the CUSF
Yes.
implementation, what about the fragility of having an additional client working through the RPC, connecting the Bitcoin core to then validate blocks after they come in, to make sure that any rules are invalidated? Couldn't that create scenarios where essentially you as a miner are kind of switching your validation logic on and off depending on if the program is working properly?
That's the point. So you don't have to restart the whole server. You just have to restart the secondary.
Yes, the question, if people didn't hear it.
Right? If you enforce the school, you can, goes down, right? All of a sudden, it's anybody can spend, okay, you
There's,
might
it's a very good question. It's a very good question. The question was, I think, if I heard it correctly, was, doesn't this, we have now a second P, instead of it all being in one Bitcoin core, you have it in a few things. If one crashes and the other people's don't, and some people's on, then won't there be inconsistently enforced rules, and then maybe there'll be like a fork or something. So, yeah, so the key thing to keep in mind about that is that is accurate, but that is actually true of every soft fork. It's just this implementation. So I think in a sense you're right that how it is implemented may affect whether or not the implementation is reliable. But I think that the bigger issue is like, okay, let's think about it a little bit more like this. The new soft fork is just, this is not like something where you're going to keep releasing a new version every 3 months. This activator will just do like the opcat 15 lines of code, and so it will be like a finished product. So it was kind of like, it will probably, it'll either crash at first or it'll be a finished project, I think. I don't know if that answers I know this is a very new kind of weird thing.
To rephrase that question as a comment, and then I'll make it a question, I guess.
Right.
This is a terrible idea to have a separate piece of software, especially if it's something like Python, because if you do succeed in getting the software activated, then that Python code with whatever subtle bugs it has becomes consensus, and somebody like Bitcoin Core will have to then re-implement it in C++ and make it permanent. But kind of what I would suggest here is if you want to activate a soft fork this way, just make a patch of Bitcoin Core. And yes, your pull request might never get merged, but you can always just release your own Bitcoin Core version that says like, this is identical to Bitcoin Core version v.29.0 with only this new opcode added.
The reason why that will not work is because of the rebasing. You have to constantly rebase.
Yeah, rebasing an opcode is not that hard though.
No, I disagree.
I think if you can't do that.
Is Jeremy Rubin in here to ask? Yeah.
No,
Well,
I would say that if you can't do that,
I refuse
you should not
to
be doing
accept
soft
this
forks,
critique.
but-
The rebasing is like an endless vampiric draw on whoever wants to do something new. And we need to this is the issue. The issue is that the existing thing doesn't work. So, and the other thing is, I had this in extra slides. I know I'm like scamming people now with this. I said I would do questions. But like, I read this paper, which is a very cool paper. I read it on the train ride up here. But it has all this new, and this is what we've been hearing a lot today about like, should we adopt the soft fork and like twiddling little, it's like, I don't know, we're changing the temperature on the faucet or something a little bit. But to me, this is a matter of life or death. Either we aggressively pursue innovation and adoption as quickly as possible, or we will probably eventually be replaced by something that does. So this is like a cheap alarmist thing, but I don't really see it this way of like, do this, do that, or whatever. I just think like this is like a huge mistake and a huge risk for no reason. And so we need something that actually works to draw in people who want, people like Jeremy. He can't be up here making a slide that says, I've been doing CTV for the last 800 years and nothing has happened. And then now later on, we decide, oh, covenants are great. No one was talking, Jeremy was talking about covenants like, whatever, like in 2016 or something. And now everyone has decided, we can't wait. We have to do something where there's the risk. This is the whole point of this idea, is it concentrates the risk in the new software, and it does not, it has no interaction with the existing software. We cannot have people forced to explain it to Bitcoin Core, because people in Bitcoin Core, no offense, you know, they don't get it.
But you're describing two separate problems here, right? One is to get a change through that you want, and maybe not everybody in Bitcoin Core wants it. And the second
not how
is
I'd phrase it, but-
implementing that change. So the first part, like if people don't want it, that's one discussion. But if you implement it in Python, which it sounds like what you're doing,
No, it's not in
you're
Python
creating,
at all. It's in Rust.
fine, you
Why did you
implement it
say
in
in
Rust.
Python?
But the point is that that change is going to be there for eternity if it succeeds. And so somebody will have to execute that
I don't
Rust
think
code for
that
eternity.
it necessarily should be. I actually think we should be a little more experimental with the soft forks. They don't need to be there for eternity, because imagine if the software crashes and is abandoned, then all it means is that the soft fork deactivates, and anyone who tried to use it loses
Loses
money.
their money,
But that's
yeah.
no different than the way the Lightning Network worked for like 5-6 years, where it was like in a state of being half completed, and people would lose money all the time. Yeah.
Okay, clearly very fruitful for discussion. A lot of questions, but I'm sorry, we're gonna have to move on to the next one. So, sorry, Marshall. Sorry, Trey. Sorry, anyone else who has any questions. But if you do, grill Paul out in the hallway over there, or in the conference room on floor 14. Also, there's coffee out there now for anyone who needs a little bit of a pickup. But with that, thank you, Paul. Appreciate your thoughts and.